Last time, I think we concluded with doubly linked list, and we have discussed all the theories related to doubly linked list. Let me take it back. And I don't think we did any practical sessions related to doubly linked list, right? So let's do that today. So those who went to the leadership program, the camp, are they here? I know that it was cancelled yesterday night, right? And you returned to the campus, and any one of them, are they here? Like at least one student? No? Okay. So doubly linked list, let's do some coding. Yeah, let's start from the scratch. I hope you have opened up Visual Studio. You can do it with me. So let's start by including the usual header files, your stream. Give me a second. Sorry for the disturbance. So start back. We included IO stream, and let's include CSTD def as well. TD def, yeah. So these two, and right namespace TD. Yeah. Okay. So let's start by creating a node. Am I audible? Have I turned? Yeah.
Yes, sir.
Yeah. Okay. So let's create the public element and let's create now. If you remember, for doubly linked list, a node has two links, right? One link is for the next node, another link is for previous node, right? Correct. So let's write the constructor. This is a default constructor. So both next and previous links will be null. Let's create an overloaded constructor. In this, we pass the value of the node itself. So element will be equal to value. Both next and previous links will be null, right? Just let me know if I'm doing anything wrong. Okay, so we have the node. Do you want some time to do the coding? Do you want some time?
Yes, sir.
Okay, leave it for you to catch up. Okay, so yeah, let's continue from there. So now we have the node class. So let's create the doubly linked list class. Link list. Under that, what do we need? We need a header, head, right? We need a head pointer. We need a tail pointer and the size, right? And under the public members or the functions, we have the default constructor, right? Default constructor. So you might be hearing some noises in the background because I'm in the home. You might be hearing some noises from my baby and all. So please excuse that. Yeah, so the default constructor, what need to have is a head equal, it should be pointing to null and tail should be null, and the size should be equal to 0, right? Because there is no nodes. Yeah. So I'm going to do this a little fast because I already mentioned the theories behind the default functions, such as insert first, right? Insert first, and there need to be an element. So so this function is about inserting a node, right? The first thing we need to do is we need to create a node, right? With element, correct? So we have created a node. The next thing we need to do, can someone tell me what's the next thing we need to do? Someone, okay, let me see. 3537 Aptanayaka. What's the first thing we need to do when we are inserting a node? 3537 Aptanayaka.
Yes, sir.
Yeah, what's the first thing we need to do?
check the head is
Check whether head is
null or not.
yeah. So by doing that, what are we doing? So when we check whether the head is exactly null or not, what are we doing actually? If head is exactly equal to null, what does that mean?
The list is empty or not.
Yeah. So that means we are checking whether the list is empty or not. List is empty or not. So yeah, one more thing when you are doing that mini project, make sure you add comments, or not just the mini project, even for the assignment. When you are doing the coding, it's better if you can include comments. I'll add a 1 or 2 mark for comments as well. So if you have the codes well described with comments, you will get a 1 or 2 additional marks. Okay, so make sure to add comments. So if the head is exactly equal to null, that means the list is empty, right? So if the list is empty, what do we need to do? So we have the temp node created. Now we just need to link the temp, we relabel the temp node as head and tail both. If the list is empty, that means the node that we are going to add will be the only node. So that both head and tail will be pointing to that node. And we need to increase the size, right? If not, else means that there's a list with a couple of nodes, right? So that's a non-empty list. We are going into a non-empty list. Yeah, so let me annotate. Basically, I'm repeating what we did last time. I don't have the drawing pad as well. So anyhow, yeah, so we have a list, all right? So we have a list with couple of elements. So this is the temp node, right? This is the temp node. So we're going to insert it to the beginning of the list. So what we need to do, we need to make this link, right? That's the first thing we need to do. How do we do that? Can someone tell me how do we do that? Come on, speak. I can't name someone every time. 3585 Fernando. How do we do this first step?
The temp.next equal head.
Yeah, temp.next equal head, correct. So the next thing, what do we need to do? What's the next step? Someone? Yeah. Yes.
Head dot previous equal temp.
Yeah, correct. So by doing that, what we are doing is we are making this link, right? So head dot previous, we are linking it to temp, because now we have bidirectional, like because we are working with doubly linked list, we have 2 links, one link pointing to the next node, the other link pointing to the previous node, right? So we need to make that as well. So how do we do that? Head dot previous equal temp, right? And then we need to shift the head from over here. Now the head is over here. We need to move the head from here to the temp node. All right, that's the third step. How do we do that? Simply head equal temp, right? And then we need to increase the size. Yeah, that's it. Yeah, so I'll give maybe 1 minute for you to complete the codes. Okay, go ahead and complete the code. So there's a question. What's the purpose of adding CSTD def library? So yeah, so that's actually a utility library there's a couple of data. It defines couple of data types and macros. Yeah, so earlier it was named as CTD def, something like that. Now the latest version is called CSTD def. So it's a utility library. So it includes some useful data types and macros. So can I clear this? I'll clear my drawing. Okay. Can we go to the next function? Have you completed this insert first method? Anybody? Dharmaratna 3568. Can we go to the next function?
Yes, sir.
Okay, we need to move a little fast. So the next function is insert last, right? So you will be coming here after the new year. So I'll be asking you to complete the codes when we do the classes physically. I'll be asking you to complete the codes. So be ready to do that. The first thing again, create the node, the element, right? Sorry. And the first thing we need to do is check whether, I'll do that by tail this time, check whether the list is empty. So a couple of ways you can do that using head pointer, tail pointer, or size variable. So if that the list is empty, so the node that we just created will be the only node. So both head and tail will be pointing to that node. We need to increase the size by 1, right? And if it is not the case, that means we are dealing with a list which has a couple of nodes. So we'll be inserting that node to the end. Yeah, so let me annotate and tell you. So there's a couple of nodes. So let's say this is the temp, right? So we're gonna add this to the end of this list. Yeah, so what's the first thing we need to do? So this is the tail at the moment, right? This is the tail. Someone tell me. Jaya Cody 3609. What's the first thing we need to do?
Tail next to temp.
Yeah. So we need to create this link tail.next equal to temp. And the second step is to create this link, right? Temp.previous should be tail. And then lastly, we need to move it to the temp. We need to move tail to temp. All right. Hope it's clear. So tail dot next equal temp first step, temp dot previous equal tail the second step, and we need to shift tail to temp now, right? The third step, and the final step is simply increase the size. Okay. Hope it's clear. So I'm going to go to the next function as well, insert at. So in insert at, we'll be using the position, right? The user has to give the position. So the first thing we're going to do is, let me clear the drawing. Okay, the first thing we need to do is to see whether the position is, given position is a valid one. How do we do that? Is we check whether the position is less than 0 or position is higher than size, right? Why this equal sign is not there? Because the given node can be inserted at to the end as well. So that's why the equal sign is not there. So if that is the case, if the position is not within a valid range, so we just output a message saying the inserted position is not a valid position, right? Else if, so we first need to check whether the given position is exactly equal to 0. That means the user is asking us to insert the node into the first element as the first element or first node, right? If not, let's check whether the given position is exactly equal to size. In that case, what the user is asking us to do is insert the node into the last node as the last node. So we'll be just accessing the functions that we created. If it is not all these cases, that means user is asking us to insert a node at an intermediate node and an intermediate position, right? So let's create a node, a temporary node now. And the next thing we need to do is we need to, if you remember right, we need to create a pointer current and link it to head, and then we need to move this current pointer from the head all the way until a position -1, right? How do we move the current pointer? Can someone tell me? Kavinda 3633. How do we move the current pointer from 1 by 1? What's the code to move the current pointer? 3633 Kavinda.
Yes, sir.
Yeah, what's the code to move the current pointer? Can you please repeat? I cannot hear you.
Current equal current dot next.
Okay, yeah, good. Current equal current dot oppo arrow dot next. Right. So this is how we move the current pointer. So while once this loop is executed, we'll have a current pointer staying right before. Let me annotate and tell you. So if you want to insert the node at this position, so the current pointer will move and stop over here, right? So the current pointer will stop over here. Now we have a temp node right over here. So we need to insert it into this position, right? So a couple of things we need to do, right? So we need to make these connections, right? So I'll just code and do. So one thing we need to do is we need to connect the temp dot next to what should we write here? Someone 3659 Madhushan. What should be the code here? Temp dot
Next.
yes, current dot next. Okay. So we have basically created this link, right? You can see there about the mouse point, right? So we have created this link. The next thing we need to do, we need to create this link, temp.previous. So temp.previous is equal to current, right? Current. And then what's remaining? So we need to create this link from current to temp. Yes. Current dot next equal temp, right? And the last one, can someone tell me what's the remaining line? So we need to create the link from this node to temp, this node to temp. How do we create that? Because we no longer have the access to this link, right? This link is no more. So how do we access this node? Someone tell me. 3726 Sandeep. How do we access this node now?
Temp next.
Yes, correct. So temp dot next means this. Yeah, temp dot
Previous.
next is this one, right? Yeah. And we need to take the previous out of that, right? Yeah, previous. So that should be
Temp.
temp. Yeah, thanks. Yeah, and the remaining code is size, right? You need to increase the size. Yeah. So that's basically insert that operation. Clear? Okay, I'll give you 1 minute for you to complete this. After that, you can go to delete operations. Can we go to delete now? Rajapaksa 3710. Can we go to delete now? Do you need more time? Three five two zero. Abhiratna, do you need more time? So let's go to delete operation. Maybe I'll give 1 more minute. Then after that, let's just do delete at. I'll leave delete first and delete last for you guys to compete. And then we'll directly go to delete at. So I'll be copying delete first and delete last from my codes. So delete first and delete that is there. So then we'll do delete at. I hope the time is enough. So these are the delete first and delete last codes, right? So if I just go through delete first, head. So we first do head. We'll check whether the list is empty, and the next thing we need to do is we need to see whether the list contains only one node. So if it's the case, we can directly delete that node. If it is not, so we are moving into a list which has multiple nodes. So in order to delete the first node, what we need to do is we first need to move the head, right, from the current head to the next node, right? So if I draw it, so this is how the situation looks, right? So this is the head. So in order to delete this guy, first we need to shift the delete to the next node. So that's how we do it. And then now head is this guy, right? So before deleting this, we need to point this head dot previous. That means this link, we need to point it to null, right? So how we do this is like this. Head dot previous equal null, and then we can delete the temp. Yeah, we had to take a point and connect it to this guy as well. So that's done over here. Then we delete the temp and decrease the size. All right. Okay. So let's go to delete last as well. So with delete last, I think these are self-explanatory. If you remember with delete last, the difference between compared to single linked list, in in single linked list, when we are deleting the last element, see this one, when we are deleting the last element, so when you're deleting the last element, if you remember, we have to create a current pointer and we had to shift it all the way up to this node, right? In order to delete this guy. Whereas now, because we have two pointers to next and previous, we can simply, right, move the tail from the tail to the previous node using this command, right? Tail equal tail dot previous. So we have shifted the tail to this node, right? And then next thing we need to do tail dot next. Now the tail is over here. Tail dot next, this link, we need to point it to null, right? Null. And then we can simply delete this, right? Clear? It's clear. So now we can go to, let me, so let me write delete at function. Delete at, the input is a position, right? So first few things are, I'm not going to explain them again. So we need to have the equal sign over here, right? So especially in the exam, if I ask a question like this, I'll be giving marks for these minor points, right? Because this is where insert and delete operations are different. So you need to remember these minor points, right? With delete, this equal sign will be there. With insert, the equal sign will not be there, right? So remember these minor but important points. So if the hold on a second. Yep. So yeah, so if the position is not within our range, we need to output a message and say that. And the next thing, what we need to do, we need to check whether the given position is exactly equal to 0. In that case, we can call the delete first function, right? If not, we need to check whether the given position is exactly equal to size minus 1, right? This is also important. You need to remember, right? The condition is size minus 1, right? Because the index start from 0, right? So in that case, we can call delete last function else, right? Else, now this is where we need to do some coding. Okay. So if I annotate, so we'll be deleting a node, right? Somewhere in the middle, right? So something like this. So we are deleting an intermediate node. So say we want to delete this one, right? So yeah, so if you want to delete this one, in this case we need to create a current pointer and move it from the head all the way until either this point or this point, right? You can do it in both ways. So let's say we move the current pointer all the way until the node that we need to delete. Okay, so how do we do that? Create a current pointer. We start by pointing to head, and we need a for loop, right? Now, so this question is actually for the male students. Have you posted your applications for the hostels? Those who wants to stay inside the hostels, have they posted your applications?
Yes, sir.
Okay. So we'll be having, so not quite sure with the current situation whether we can give you accommodation right away, because the situation is in hostel C, we have the ground floor separated for you, and I mean, we need to give some beds to the union president and couple of members from the union, and we need to allocate some rooms for sports captain. So altogether we have about, I think, 18 rooms in the ground floor, right? So however, we don't have mattresses. We have asked for the mattresses, and the TEC and the bidding and everything is done. So we have handed over the bidding. We have found the supplier. uh, Not sure whether, because the dollar rate is going up and up, so sometimes we have experience in the past also, when we hand over the bids, the supplier sometimes is reluctant to provide the items, because the bid that he made no sometimes back, the price is no longer acceptable, right? So because the dollar rate is going up, so he needs a higher price. So sometimes the suppliers goes back on their quotations, and they ask for a higher price. So in that case, we have to call for bidding again, and so there's a lengthy process. So hopefully, if they provide the mattresses, we can give you the rooms right uh, when you know, enter the university on 18th, I believe, right? So there's a slight possibility that it may not happen. So I'm just going to, I mean, I don't know actually. So what's going to happen, right? And there's actually a possibility that we may not be able to bring you even, because if the situation get worse, especially the power crisis. So no, that's also a possibility, right? I mean, we are finding it even hard to do lectures. Some of the lectures even yesterday got cancelled because there was no power. Generator is not running, right? There is no power, and we can't, without power we can't even turn on a computer, right? So somehow I managed to do the lectures, but some of the lectures in the morning were cancelled. So I'm just giving you the picture, right? So you have to expect that when you come to the university, that everything may not go smooth, right? Because of the current situation in the country. Okay, so what we have done here is we have created a current pointer, and we have started from the head and moved all the way until the node that we going to be deleting, right? One more thing we need to do, yeah, we need to create a temp pointer, and yeah, now the temp pointer is pointing to the current node which we are going to be deleting, right? Yeah, okay. Yeah, so then comes the tricky part. So I'm going to ask from someone, now we need to delete this node, right? So can someone tell me what are the steps involved in, what are the remaining steps involved in deleting this node? Can Lianage 3655, Lianage, can you tell me what are the steps involved in deleting this node? So the current pointer is over here.
Current next point to the
Yeah, current dot x, now this guy, right? Current is
Yes.
over here. Current dot next is this guy, right? So current dot next
to the
just, even if you think, you can find out the answer. So current dot next is this guy. So basically what we need to do is, if we are going to delete this guy, we need to shift all these, redirect all these link, right? So that's what we need to do. So current dot next is this guy. So we need to create this link, right? This link we need to redirect it to over here, right? So current.next is this, current.next.previous should be pointing to this guy. And how do we access this guy? Someone tell me. I'll write part of the code and then someone has to tell me. Okay, so current.next is this guy, right? And the previous link, his previous link, right? Previous link. What should be the out? What should we write here? Malkit 3664. So we are basically talking about this link now.
Current dot previous.
Current dot
Previous.
previous. Yeah, okay. Current dot previous. So temp dot previous, both are acceptable answers, right? So next thing, so we did this link, and what about this link, right? So this one, right over here. Let me annotate maybe this link. So we need to create this link now. So how do we do that? Current dot previous, right? So in order to access this guy, so that guy is current dot previous, and his next link, right? His next link, that means this one should be pointing to someone. Tell me. Vijayvant 3787.
To current
Yeah.
dot next.
Okay. Yeah. Good. Current dot next or temp dot next, both are acceptable answers. Yeah. Good. So then now we have configured the links. Then we can go on and delete the link. So delete the node size. Then we have to decrement the size by 1. Clear? Okay. Just take a minute to complete this. Then let's move on to here. Okay. This is still for the written, still for the doubly single link, please. So we change it to doubly. Let's refactor this. How do you change the variable? Remember its rename. So let's type it as DLL. Yeah, everything changes to DLL now. Oh, we don't have the print function. Let's just take the print from here. The print won't be different. It's the same. So let's take the print from single linked list and copy it to double linked list. Right? It doesn't matter. So let me clear the annotations. Okay. So yeah. So let me first. I think this is quite clear for you, right? I don't think need to look into. Okay, let me take this out and run this. Meanwhile, if you have any questions, please ask. You can even type in the chat. Okay. So, line number 150. Yeah, this might, I think this should also be position -1, right? So let's see. Let's try it out. Probably, yeah, probably it's a mistake on my part. Let's try it out, right? So this is the last linked list that we have created. Probably in the print function. Now we need to have the link into both ways. So let's just do that. So, okay, so this is the linked list we have, right? So let's try deleting and see, check whether it's working. So DLL delete. Let's try delete first, and then print, right? And then let's try delete last, right? And then try out printing. Okay, let's first try these two. So this is the list we have. Let's see whether, okay. So the first line was we first deleted the first node. So 23 is gone, right? And then we deleted the last node. So 7, right? 7 is gone, right? These two are working. Let's try out the middle one. Delete at maybe second node. Let's see whether it's working. Okay. So let's try it out. Second node is, okay, go over here, right? So 0, 1, 2. Yeah, 0, 1, 2. Second node is gone, right? Correct. Right? Yeah, second node is gone. That means delete at is also working, right? So I probably thank you for the comment, Kumar Singh. So probably the confusion is, so you were suggesting that this needs to be position -1, right? So as I mentioned, so delete operation you can do in couple of ways. So what I have done over here is, so if you want to delete this guy, probably you can double check. Maybe it's always possible that I might be mistaken. So let's just work it out. Okay. So what we need to find out over here is whether the position, whether it should be position -1 or position. So let's say, so the nodes are, so this is 1, 2, 0, 1, 2. So we need, so let's say we want to delete the first node. So 0, 1, 2. We want to delete the first node. So I mentioned that in this code, what we have done is we have shifted the current pointer from starting from here to all the way until the node that we're going to be deleting. So let's see whether it's the thing that's happening. So from in the start, the current pointer will be over here, right? Pointing to the head, and now position is 1, right? Position. So we are deleting the first node. So the position is 1, right? So I equals 0, position is 1. So we'll go into the loop, and the current pointer will be shifted to over here, right? And we go from over here, I will be 1. So then the loop will break, right? So the current pointer won't move from here. So the current pointer will end up here. So that's correct, right? I guess the confusion was earlier in single linked list. What I did was we shifted the current pointer up to here, to a node that is right before the node that we will be deleting. So it ended up over here. So it ended up over here. Whereas in this example, I moved the current pointer all the way up to the node, right? Is this clear, Kumar Singh?
Yes, sir.
Okay. So any questions? Anyone? Any questions? Any questions on the mini project? Any questions on the assignment even? Can we write the assignment code to get input from user? Yes, it's possible. So both ways are okay. So I believe you are talking about this main function, right? So you can just try it out by just giving some example. That's also fine. Or you can ask the user to insert the number of nodes that needs to be there. So that's also possible. However, now when I'm evaluating, right, it's better if you can send me both. Like you can send me a main function or main file with user inputs as well as another main function with where the user can insert the inputs, because it's, uh, for the evaluation I might be using this one where you manually you hard code the inputs. So I might be evaluating that one, so it's easier for me to do that. So it's always better if you can do the other way as well. So send me both files so that I'll go through both. Okay. Any other questions? So next week we'll be working on stack, right? So now we have completed both arrays and linked lists. Both are physical data structures, right? So we'll be moving on to logical data structures from next week. We'll be starting with stack and queue, and then we'll learn about trees, graphs. Probably you will learn from Mr. Nilmanta under the algorithm part. So yeah. So we have stack, right? Should we upload test scenarios of our coding? Yes. So just that is important. I mentioned right in the thing in the last in this assignment. Yes, the assignment. Yeah, this one. So I need both linked list class and the main file. Under the main file, you need to have the test scenarios, right? What I mean by test scenarios is this. So you need to have these things, right? So this needs to be there, and add comments whenever possible. So I'll be giving a couple of marks for comments as well. Yeah. Anything else? I believe the time should be enough. If not, I mean, in the sense like we skipped one Friday, right? We couldn't do lectures on one Friday. So let's see whether we'll need another lesson or not. Just using insert plus is enough for testing. So I believe you are asking about the assignment, right? So the assignment was on delete with, yeah. So yeah. So I won't be evaluating much on insert. Now the assignment was on delete operation. No? So this one you can either use delete first, sorry, insert first, insert last, insert add. Somehow you need to create a linked list with a couple of nodes, right? So that better. So now okay. So one thing is when you are creating test scenarios, it's always better to your test scenarios should test out all the possible events, right? For example, now this is the perfect test scenario. This one, where this test in this test will be I mean we'll be testing. So your delete with needs to tell delete when there's a node with value 5 in the beginning. Your delete with function needs to delete that. When there's a node at the intermediate position with the given value, your delete with function needs to delete that as well. And at the same time, if your node is at the end, your delete with function needs to delete that as well. So your test scenarios should test all these scenarios. So remember, I'm going to repeat it again. Now, your test scenarios, the linked list that you will be creating, right? like this. So here what we have done is we have created a linked list, right, with a couple of nodes. So this linked list needs to be something like this, where a node should be there in the beginning with the given value. Node should be there at the intermediate point. Node should be there at the end. And this now there should be two nodes. I'll be, if you don't create this test scenario, this perfect test scenario, I'll be creating by myself and I'll be evaluating on that. But I'll give a one or 2 marks for a perfect test scenario as well. So perfect test scenario is something like this. So node should be there in the beginning, node should be there in the middle, in the end, and node should be there in the beginning, in the middle. And it's better if there are a couple of nodes right next to each other in the middle. So this is actually hard scenario you need to test out. So your code needs to be working with such scenarios as well, where there's a couple of nodes with the given value. So you will need to delete these 2 nodes as well, right? So when you are writing the test scenarios, make sure you have a linked list, something similar to this. Okay. When is the deadline? Okay, deadline. Today is 4th, right? How much time do you need? Can we have the deadline as 8th? Is 8th okay for you?
Sir, can we take it after New Year vacation?
Okay, who's that?
Sarang.
Okay. Okay, then I'll give you the New Year vacation as well. So make sure to submit by this is the New Year vacation, right? Oh, you can't see the you can see the calendar. Okay. So we are over here, right? So New Year vacation is this one. Can you submit by 20th? 20th is fine.
Okay, sir, it's fine.
Okay, so the deadline, take it as 20th. Okay. Yeah, so I'll put a link to upload the project, the assignment in the LMS. There's a couple of questions. So if we use one insert function instead of 3 insert function, is that okay? Can you elaborate? In one insert function, you mean the insert at, insert first, insert last, these 3? Is that what you mean? Kumar Siddhi?
Yes, sir, that rather than we use insert first or insert at or insert last, can we use insert element like
So
that function only?
yeah, I mean, for this, it's okay for you to, yeah, that's fine. So doesn't matter as long as you have that perfect test scenario. I mentioned the perfect test scenario, right? A node should be there in the beginning, node should be there at the end, a node should be a couple of nodes right next to each other should be there in the middle. I mean, what I mean by node is node with the given value, right? That is clear, right? So node with the given value in the sense, if you are deleting 5, there should be a couple of nodes in the middle with 5 right next to each other, right? So in order to create this link, you can use insert first, insert last, or insert at, anything. So it doesn't matter. I'll be more concerned on the delete operation. However, your test scenario should look something like this. Okay. When is the deadline for the project proposal? That's 8th, right? I mentioned. That's I mentioned it in the beginning. It's 8th, right before the new year. Okay. Any other questions? Any questions on maybe regarding coming back to the faculty after the new year? Any questions on that even? Can answer as the board.